Okay, I got a call that last video. So basically, as you notice, I have already started out. So let me re-explain the steps. We want to figure out pi. Pi is defined as the circumference divided by its diameter. Basically, this length right here, which we are calculating to be 1/2 at the distance of 1/2 from 0 to 1/2, is basically going to give you 1/6 pi. Remember that 1/6 because that's going to come in handy later. Now, this circle has the function x squared plus y squared equals 1. And basically, you want to take, okay, you subtract x squared from both sides. So you have 1 minus x squared. And then you take the square root to get rid of that squared on the y. And this is the same as saying 1 minus x squared to the 1/2 power. There's a magical 2 there. And you can think of this as like the exponent division. So whatever exponent you have divided by whatever number in here. So if there was a 3, this would be to the 1/3, and so on. Now we want the dy dx, the derivative, equals, you drop the exponent, that's where this 1/2 comes from, everything in the inside of everything of the inside, and you subtract 1 from the exponent. So 1/2 minus 1 gives you negative 1/2, and times the derivative of the inside. That's the chain rule. So the derivative of 1 of a constant is 0, so you don't have to worry about that. But negative, we have negative, we drop the exponent, x minus 1. So x squared, 2 minus 1 is just 1. So we can just leave it like that. Now, so using algebra, let's see, this is the derivative. Okay, now that we have the derivative, we want the arc length. Because using the arc length formula, we will figure out what is 1/6 pi if we go from 0 to 1/2. So the arc length from 0 to 1/2 of this function is the same as the square root of 1 plus dy dx squared dx. Whoa, that's ugly. So that's why we wanted the derivative, because we're going to plug it into this formula. This is the arc length formula. Arc length. Okay, so you want the integral from 0 to 1/2 of the square root 1 plus, okay, dy dx is all this squared. So we're going to use parentheses, 1/2 1 minus x squared to the negative 1/2 times negative 2x. Remember, x to the 1 power of 1 is just the same as x. And you're going to take all this and you're going to square it. You're going to take all this and you're going to square it. This is all under square root dx. So the integral from 0 to 1/2 1 plus, let's see, we can cancel this 1/2 with the 2. We're going to square the negative, so it's going to become positive anyways. So let's do that. Okay, what do we have left? We've got 1 minus x squared to the negative 1, because we distribute this times x squared. We distribute this squared into this x and into this negative 1/2, which gives you negative 1. So basically, okay, you want the integral from 0 to 1/2. Okay, so this is your denominator. I'm going to skip a lot of steps here. So 1 minus x squared over 1 minus x squared. That's your 1. Plus, and this is basically x squared, because this is being multiplied. This is multiplication over 1 minus x squared. Now, these will cancel. These will combine. So that stays the same. This is just 1 over this. So basically this 0 to 1/2 of 1 over square root 1 minus x squared dx. Okay. So now that we have the arc length from 0 to 1/2 of this, and remember this is 1/6 pi, so 1/6 pi is equal to this. Basically you're basically saying that pi is equal to the integral from 0 to 1/2 of 6 dx all over square root 1 minus x squared. Now, given this formula that we started out with at the very beginning, actually, this is the wrong formula. You want the definite. And that's basically saying that the integral from a to b of a function is equal to, what is it equal to? The limit as h approaches 0 of the summation I equals 0 of b minus a over h of f of a plus ih times h. And the reason you use a and b is because we have limits here. Okay, the general form works if you have nothing. This is the generalized form. You just want the anything of it, whatever. But because you have limits, you have an a to b, you kind of want to make the substitutions. It's the same thing. It's exactly the same thing. You're just plugging in values, basically. You're just plugging in values. Okay, so limit was, so basically you're saying that pi is equal to the limit as h approaches 0 of the summation I equals 0 of 1 over 2h all over 6h square root 1 minus IH squared. And this is how you calculate pi. Without trigonometry, by the way. The index is part of the formula, not some sub. And there's no trig functions. You can plug this into a calculator. And the trick, what this is saying, is basically to let your h's become smaller and smaller. So you start with something like 10 to the minus a million. So you would plug in 1 over 2 times 10 to the minus a million, 6 times 10 to the minus a million, all over the square root of 1 minus I times 10 to the minus a million squared. You know, whatever. Plug that into a computer. And then you get it even smaller. Then it's 10 times 10 to the minus a billion, then 10 to the minus a trillion, then 10 to the minus quintillion, and keep going until you're satisfied, basically. You can keep going forever. That's the beauty of this. Pi goes on forever. And this is how you get it.